Hey guys, so we're back. So good afternoon for the students that were not in the morning class. You know, um,
Good afternoon, everybody.
yeah. So today we're going to speak about how to design a highly available infrastructure, and this is going to be section one of two sections. Today we're going to see section one. I have a question for you. So far, what do we know about high availability? So far, what do we know?
That it's basically how easily accessible the systems are, and the frequency to which they are, like 99.911, like 9911, like what was it? The hell you had said it was 11 nines.
11.9. Yes.
They will always be available. The system will always be up and about.
Okay. So what else can we say?
I'd say that it's like high availability would be the like if a server goes down, how much time would it take for it to go? How much downtime would it have? So if one goes down, the more availability, like the less downtime, it'll be up quicker again.
Is it a big downtime or is it minimized?
It's minimized. If you have the highest availability possible, it'll be a minimized downtime.
Good. So how many AZs are recommended?
2 or more.
2 more. Very good. How many subnets?
One private and one public for each availability zone.
That's right. One private, one public. Very good. How many servers?
Minimum 2.
How many servers?
Minimum 2.
Minimum 2. Very good. Very good. So that's basically what we've seen so far, how to make something highly available, even though it seems that we are repeating the same and the same and the same. New concepts are being added to this huge concept of high availability. Okay, and that's what gonna be in the test. Basically, it's oriented to highly available architecture. So in this module, we're gonna see high availability and scaling, automating, and decoupling. Okay, and if you are in the morning class, you may realize how useful knowing the basics is. Uh, because if you start from the associate level, you're gonna be a little lost, because things are coming from somewhere, and they come from the basics, right? So part one, load balancing and fault tolerance. Exercise will improve this architecture. An exercise like the one that we did on Wednesday. We have part two, high availability across regions. Part three, connections outside of the Amazon VPC. We're gonna have some lab. Not today. The first lab is gonna happen on Monday. Okay. Not today. And the discussion is gonna be in another class. Okay? So Upon completion of this module, you will be able to define what is meant by availability, fault tolerance, and scalability, and discuss how those concepts are related and used in cloud architecture. Discuss how to avoid a single point of entry, single points of failure. I'm sorry. We have to have a single point of entry, but we have to avoid single point of failure. It's like having only one architecture, only one EC2, only one availability zone, only one region, for example. We are avoiding that point of single failure. Identify which AWS services have built-in fault tolerance and which can be designed for fault tolerance. Explain why load balancing has become a key architectural component for many AWS-powered applications. So part one, load balancing with fault tolerance. So this guy, Werner Vogels, the CTO of Amazon.com, once said, everything fails all the time. So that was the idea that's behind all this HA in AWS. Everything fails. So we have to plan for failure. That was their initial concept. We have to plan for failure. So if something fails, what are we going to do with it? So that's a pretty smart move, because if you start building something and you don't plan that something might be broken, then you're going to be in trouble when that time comes. So maybe the time never comes, but you have to be ready just in case it comes. So this guy was clear from the very beginning. He was enlightened. He had a vision, and he said, wow, we have to build just in case something happens. We have to be ready for that. Okay, so what is high availability? Maybe someone asked you a question. I think that I asked you a question at the beginning of the class. So high availability, or HA, is about ensuring that your application's downtime is minimized, like you guys said, and as much as possible without the need for human intervention. So we are trying to keep the human component out of this. We're trying to automate everything. Okay, automation. What is automation? We don't need any human intervention. No humans. This is all automated. Okay, so we have the level of availability. So in the case of 1.9, in the case of 90, for example, 1.9, what it means is that the maximum downtime per year is 36 days and 5 hours, right? Which is equivalent to 2.4 hours per day, okay? And let me tell you something, that's really high. That's really high. Can you imagine if you're watching a movie and on a streaming service like Hulu, or I don't know, Netflix was the other one, any other one, those streaming services. Can you imagine if you have like 2 hours and let's say
or a
hours and
transaction
20,
loss for a bank.
I'm sorry?
I say that it's a lot of time for transaction loss in a banks too. Banks.
Yeah. 2 hours is equivalent to 2 hours and 20 minutes, more or less, 25 minutes, more or less. That's a lot of time. That's a lot of time. That's a downtime that is huge. So that's gonna cost some money to the business, and that is not good. Okay, the 2 nines, 99%. Even though it's 99%, just 1% to get to 100, that represents 3 days and 65, probably 3.65 a year. Probably 3 days, 6 hours and 50 minutes, 3 hours, a little bit more than 6 hours. That's a lot of time too. It's got 14 minutes per day. That's still high. That's still high. 14 minutes. If I have to wait for 14 minutes for Netflix to have my movie back and running again, I would call Netflix and ask for a refund for that particular day or that particular month. That's too long, very long. And by the way, Netflix started like I don't know when was it, probably 2000. Well, started some years ago, many years ago. But I remember that 5, 6, 7 years ago, you used to pay like $8 a month, and right now we're paying $14 a month. So they're increasing the monthly payments cent by cent, just per se, and they're making millions of dollars. Whatever increase they make, they're making millions of dollars. So it's a pretty smart move. And 50 cents or $1 may not mean anything to us. It's just 50 cents. But can you imagine if every customer pays 50 cents, and they have millions and millions of customers? How much money they're making a month? Tons of money, right? So if you have 3 nines, 99.9, that's gonna be 8 days and 76 hours, like 7 hours, almost 8 hours a day. That's 86 seconds downtime per day. So if you have 4 nines, 99.99, that's 52 minutes and 6 seconds. It will be 8.6 seconds per year. And 5 nines, that's gonna be 25 minutes per year. That's 0.086 seconds per day. Okay. These are level services, these nines. Well, AWS can guarantee for some services, most of them, 11 nines. So 11 nines, can you imagine? If 5 nines is just 0.86 seconds, can you imagine 11 nines? That's super fast. So, but this chart is for you to have an idea of downtime. How is it represented in high availability in AWS? So avoid single point of failure. So implement redundancy where possible in order to prevent single failures from bringing down an entire system. So we have here the anti-pattern. What do you see here, guys? What do you see here? Tell me what you see in this graphic.
That none of the servers are reaching the database because all of them are down.
They're down, right?
Yep.
And the database is down too.
Yep. Everything is down.
So obviously this architecture needs more application servers, right? And it needs more databases. Okay. So avoid single point of failure. So what's the best practice? What's the best practice? So what do we have here? We have 4 application servers, right? Or in this case, we have 2 in every scenario. So if something happens with the database, the primary database, what do we have? We have a secondary database, which is a replica, right? And the replica, what happens with actually it's not a replica, it's a standby server. A standby server, which is a replica, but it is not working. Okay, the standby is not working. It's there just in case a disaster happens. It will fail over. It will be promoted to a master database. So the M stands for master, and the S stands for standby. Okay, so in this case, we have 2 servers that are fetching information from the master database, which is the primary, right? Now, if the primary goes down, if it goes down or goes offline, what happens? These guys immediately will fail over. All the information here fails over to the standby, and the application servers will come and fetch the information from the standby database, which is not the standby anymore. Now it's being promoted to the master one. Okay, so all the reads and all the writes are going to happen here. Okay, before this disaster happened, right? This guy here was not working. Of course, every time something is written here, is replicated here, right? It's replicated, and this is synchronously. Okay, it's a synchronous replication. So when you see here, instantly you're going to see here. but this one is not going to do anything until the primary fails. Okay, that's not the same as a replica. A replica is working to improve the performance. So you have to understand the difference between a standby database and a read replica. Okay, two different things. We're gonna see read replicas later. Okay, but this is to improve the availability of your database, right? By having another standby, and then it will fail over to this. Usually you put this guy in another availability zone, okay? So one availability zone for this one and one availability zone for this one. So when this guy, which is the master one, completely goes offline, including the availability zone, like a disaster or something, it will fail over to this one, and the other availability zone will be up and running. Okay, very good. So that's what happened. What basically happens. We're guaranteeing high availability and avoiding this guy here, which is basically this point of failure. Okay, this is a point of failure. Okay, high availability driven by your requirements. Recover time objective, RTO. Does anyone know what RTO stand for? I mean, what it means, what it is?
That's the amount of time that you can, let's say, sustain being down.
Okay, good. So the RTO is how much time you can afford to be offline. Okay, that's the RTO. And the RPO,
I guess.
The point of recovery, how far you want to go back?
okay,
Or how much data you can afford to lose?
that's right. That's right. So the recovery time objective is how much it's going to take you to recover, right? How much time you can be down, right? And here is how much data are you willing to lose, okay? You can afford to lose. Now, these are two of the questions that you have to ask a business owner. Okay, what's the RTO and the RPO that you are looking for? Okay, how much you can afford to lose, how much time you want to be back and running. Okay, the smallest the RTO, the more expensive it's going to be. Okay, the smaller the RTO, the more expensive it's going to be. Okay, so it means that, you know, if you're faster, you're faster in getting back up, you have to pay more. Okay, so how much money do you need to invest to meet those objectives? Those are questions that you asked. You need to ask a business owner. Okay, that's part of the highly available architecture. Here we have some factors: fault tolerance, recoverability, and scalability. What is fault tolerance? Is the built-in redundancy of an application's components. Basically, fault tolerance is how functional and operational I can be in an event in case of a disaster. So that's fault tolerance. I can still be operational and functional even if there is a disaster. Okay. Okay, the process and policies and procedures related to restoring service after a catastrophic event. That's recoverability. It's the ability to be recovered. Okay, and the scalability is the ability of an application to accommodate growth without changing design. So we don't have to change any coding, any design or anything. We just need something that helps us be more scalable, and then we're gonna accommodate and adjust to any growth or any growing capacity in our application. Okay. So on-premises versus on-premises HA versus HA on AWS. Okay. Before we saw the difference between on-premises and AWS, we know that there's a huge difference between the two of them. Okay. Each one has its own advantages that we spoke about, right? But when you you go to the balance and see which one is heavier, I think that AWS has many more advantages than being completely on premises. Okay. So in traditional on-premises IT, high availability is very expensive. You have to work more. You need more people. You need more resources, right? And it's suitable only for absolutely mission critical applications, just in case for security purposes and security reasons, you want to keep everything on premises, right? Right. Something that is, confidential or highly sensitive, you rather keep it on premises, because you want to be more confident and more secure. Now, AWS expands availability and recoverability options by enabling you to use multiple servers. Okay, when we scale out, what are we doing? We're increasing the number of servers, right? Isolated redundant data centers with each availability zone. We discussed this already. We said that availability zone is an um, isolated area, fault tolerant, that doesn't depend on the other ones, and it's like 50 miles apart from each other and for one another. We have multiple availability zones with each region. There are several availability zones per region that you can use. In the case of RDSs, you have to enable multi-AZ, the multi-AZ feature, to be able to have your database in different availability zones. And you have fault tolerant services in AWS, like we spoke before. And also, of course,
They might be sleeping.
of course, the
I
region
think she might be sleeping.
across.
I think she might be sleeping.
Can you please put yourself on mute?
Okay, I'm trying to set all the mics on mute. Okay. So, of course, we have several regions across the globe, like 24 and 3 in the works, like we spoke about last class. Multi-region deployment increases availability and increases what? In the middle? What is this?
Cost.
Cost, right? Of course, you're highly available. Of course, you are more resilient, more redundant, but you have to pay more. Okay, you have to pay more. And of course, it's more complex, right? You have more resources, you have more availability zones, you have more regions, you have more features. It's going to be more complex, much more complex. So the default to a single region unless multi-region deployment is necessary, okay? If you need to deploy multi-regions, then you can do that. But a single region, I think it is, I think a single region is good, right? And if you use a single region, multi-AZ is the bare minimum HA solution. This is for databases, right? This is the feature that RDS has. Now, if I go to here, if I go to AWS, right? And here I put RDS. And I want to create a database. Okay. Here I have the 6 engines that AWS RDS supports, right? So it supports Amazon Aurora, expensive as hell, super expensive, because it replicates automatically, and it have up to 15 copies of each automatically. When you create an Amazon Aurora database, it automatically creates 6 copies in 3 availability zones. So 2 in one, 2 in the other one, and 2 in the third one. That's automatic. And this is for high-end companies, right? Expensive, okay? Highly available, but expensive. So we also have MySQL. You can have MariaDB. Maria, this is for you, MariaDB. You can have PostgreSQL, Oracle, Microsoft Server. In this case, I'm going to choose Postgres, okay? Postgres. So I can choose this here. I can select production, development, test, or free tier. Let me see that particular. You see here? Can you read this, guys?
Yes.
Okay. This is multi-AZ, right? So you create a standby instance recommended for production usage. It creates a standby in a different availability zone to provide data redundancy, eliminate I/O freezes, input/output freezes, and minimize latency spikes during system backups. Okay. Of course, when the system backs up, right, there's a downtime process, right? But it will it will fail over to the other one, to the standby one. So the downtime is going to be minimal. Because sometimes you have to back up the database. Okay. So if you choose the free tier, of course, you're not going to have the multi-AZ feature. That's only for the paid databases, right? So here you can set up the master password, I'm sorry, the DBT distance. You have some here that you can choose. This is the type, the family type, of all the types of the classes that you have here. For large, you can include previous generation classes. You can have your provision IOPS or general purpose IOPS. When we get to volumes, all that, we're gonna understand this a little bit better. You can allocate gigabits, gigabits. This is gigabits. It's a little bigger than a gigabyte. So we have provision IOPS 1000. You can increment this or decrement this, right? You can have storage auto scaling, right? Enable auto scaling. Enabling this feature will allow the storage to increase once the specified threshold is exceeded, right? So the threshold is here. If it is more than 1000 gigabytes, I'm sorry, gigabytes, then it will auto scale, okay? Here, connectivity, you can put that inside a VPC or create a new VPC. What it says here, after the database is created, you can't change the VPC selection. You can't. So you got to be careful with this. You can have some additional connectivity here. If you want your database to be publicly accessible, you have to select yes, right? Otherwise, no one will be able to access the database. When I say public is available, is like you use a third party, for example. Have you guys ever used dbeaver? Never?
No.
Okay, dbeaver it's a platform that is used with databases. You can create the database there in dbeaver. It's like a IDE, like an integrated development environment for databases. You can choose an existing security group, or you can create a new one right here. Create a new one. Just like EC2 EC2 instances have a security group, also do RDSs, databases. So look at the cost, right? You see the cost? Look at the feature. How much is the feature?
to almost $260.
You see, if I don't have that feature, it's gonna be how much? This on this,
200.
this plus this,
Mm-hmm.
right? So this minus the feature. Okay, so as you can see, it's expensive, right? Okay, so I don't care about this. I'm not gonna create anything now, but this is basically it with databases. You can change the type, you can change the capacity, you can change, you know, everything to your liking. Okay. Okay. One moment. Okay, so we have AWS services and high this on your left-hand side, you have all the services that have HA by default. It's inherent by default. So you don't have to do anything. You don't have to do anything to make these guys highly available. They are by default already highly available. Okay. So in the right-hand side, these guys can be highly available, but you have to do it manually. Okay, you have to make them highly available. In this case, you have to create auto scaling, you know, elastic load balancer, all that, right? In this case, you have to do something similar, create 2 VPCs instead of 1, Amazon Redshift, warehousing, elastic cache, AWS Direct Connect. So if you want to make this connection more available, you have to create 2 instead of 1. And not all services are here. Okay, that's something that you need to understand. There are many more, but these are the most common ones in AWS. Okay, so elastic load balancer. What is an elastic load balancer? It's a managed load balancing service that distributes incoming application traffic across multiple Amazon EC2 instances. So what it does is it fully managed? No, it's managed, right? So there's some configuration that you guys have to do. Okay. Now, automatically distributes incoming application traffic across multiple targets. What are the targets? The EC2 instances, right? The EC2 instances, they are the targets. I'm gonna show you. I'm gonna give you a demo of how the EC2 instances can be registered to a load balancer. Okay, such as Amazon EC2 instances, containers, and IP addresses. Okay, it handles. By the way, an elastic load balancer has an elastic IP. Okay, it has an elastic IP. The IP of an elastic load balancer will never change. It's elastic. Okay, it's like a static IP address. So it handles loads of your application traffic in availability zones. To be able to work with an elastic load balancer in multi-availability zones, you have to enable cross zone, the feature, the enable cross zone feature. You have to enable that. Okay, elastic load balancer by itself doesn't work out of the availability zone where it is created. Okay, it's a zone specific service, right? So you have to enable cross zone to be able to use it in a different availability zone. So it's three types of load balancers featuring high availability. It's highly available when you enable this cross zone feature. It automatic scales, that's true, and it has a robust security. Remember, it's managed. So you have to do some configurations there, right? Now we have three types of load balancers. Three types. Application load balancer that works, that operates on layer 7 of the SCI, of the OSI, I'm sorry, OSI, which is the transport layer. If you want to know more about the OSI model, you can Google it. It's an OS, it's for networking. And this guy, it operates on the level, not transport, it's the application layer. It's number 7. That's why it's called application load balancer. So it's flexible. It has advanced load balancing of HTTP, HTTPS. So it works with HTTP and HTTPS. Very important. That's what makes this load balancer different from the other ones. It operates and a layer 7, which is the application layer, and also it works with HTTP and HTTPS, port 80 and port 443. Okay, don't forget that. Now the network load balancer. The network load balancer is a balancer that operates on layer 4, which is the transport layer, right? It is designed to handle tens of millions of requests per second. So can you imagine that? Tens of millions of requests per second while maintaining high throughput at an ultra low latency. Ultra low latency. It's super fast with no effort on your part. So there's no human intervention. This is all automated, okay? So this is a very powerful load balancer. Tens of millions of requests per second. Don't forget that. Ultra low latency, okay? Very good to understand this. Very important, okay? So it's ideal for load balancing TCP traffic, and it's capable of handling millions of requests per second, like I said before, and it's optimized to handle sudden and volatile traffic patterns. So those traffic patterns that are constantly changing, this is the guy for that, okay? And it uses a single static IP address per availability zone, okay? This is very important. Remember, you create one availability zone load balancer, and it's gonna have a static load balancer, a static load IP address for that particular availability zone, okay? Now we have the classic one, which is like the legacy one, is the one that was the previous generation. It's the combination of both. So this one was the first one that was created that operates on both the layer 7 and the layer 4. But Amazon decided to create these two others to separate it, right? One operates on layer 7 and the other operates on layer 4. Okay. So what is this used for? For existing applications that were built within the EC2 Classic network. Okay. When you say EC2 Classic network, it's the EC2 instances that were created outside of the VPC. That's the classic, the EC2 Classic. Okay. So remember, when you hear EC2 Classic, that means all those EC2 instances that were created outside of VPC, right? Now, if you create them inside of VPC, then they're not EC2 Classic instances, right? Now, this one, like I said before, operates at both the request level and the connection level, transfer, operation, and transport, layer 7, layer 4, okay? So why would you choose an elastic load balancer, okay? You can work with an elastic load balancer. That's not a must. But if you use them, it has some benefits, right? So what does it provide? High availability, of course. You know, the elastic load balancer has a health check, like the second point. It has a health check that will check every certain amount of time if the EC2 is, it's operational, right? If it is healthy. And then if it is not healthy, like I've said many millions of times, it will not send traffic to that EC2 instance anymore and continue sending the traffic to other EC2 instances. So it's highly available, right? It has security features. right? You can have some, you can enable access logs where it will tell you what IP address try to access the EC2 instances using the elastic load balancer, right? TSL termination, when the connection is made, what it does is it provides an integrated certificate management and SSL decryption, which allows you the flexibility of centrally managing the SSL settings of the load balancer and offload CPU. This is a very advanced topics of networking. You don't have to worry about that. What it basically does, the TSL termination, is just once it establishes connection with the requester, with the one making the request, it terminates the connection, and that's it. Okay, no more connection with you guys. So that's TSL termination, right? So layer 4 or layer 7, load balancing, depending. If it is application, layer 7. If it is network, layer 4. Okay, and if it is classic, both network 4, layer 4, or layer 7. Now, multi-load balancer pattern. So assign multiple load balancers with different settings for the types of devices that are accessing the web application. So here we have two elastic load balancers, right? Here for HTTPS, getting any request using port 443, right? A secure request, right? And also you have here another elastic load balancer only for mobile requests coming from a mobile device, right? And here we can use the sticky session. The sticky session is important because the mobile application need to keep those sticky sessions. Now for the stock users, it is common not to require sticky sessions. It's this case, desktop, right? And this is for mobile. It's good to have sticky sessions because it will bind these users to these EC2 instances. And then every time they ask for a request, it will come to the same EC2 instances, because there's a bind between these EC2 instances and then mobile application, the mobile users here. So here you prepare each load balancer for each SSL or TSL. These are transport protocols, right? Secure socket layer and transport layers. Socket, I think it is. Transport layer security, something like that. Okay, these are transport protocols, right? So a certificate right here, that's why you have this padlock. If you take a look at the Amazon URL in your here, let me see here. If you take a look at this, I don't know if you can see this padlock here, right? That says connection is secure. It means that this website has a certificate. It's valid here. Okay, it's secure. This is something that you have to buy, right? When you have a website, you have to buy it. Okay, and you have to install it, put it in your website with the host provider. It will give you the that capability to put your certificate in your website, right? So these EC2 instances are under the control of the elastic load balancers. Okay, so no one can come to these EC2 instances from anywhere. Okay, they have to come through the elastic load balancer. That's what we call, and what we spoke about, a while ago, a single point of entry. Okay, I'm entering just through this guy. Okay, through this guy only. A sticky policy configuration. So defines a cookie expiration. Do you guys know that whenever you are signing or whenever you visit a site, there's a cookie. There's cookies involved. Okay, a cookie is a code that is attached to the user. Okay, that's why. Has any one of you created an ad on Facebook? Never? Advertise on Facebook?
No.
Never? Did
Yes,
you know?
sorry, I'm talking and I'm on mute. Yes, I have.
Yes. So do you guys know that Facebook knows where you've been recently
Yes.
on the internet? How
Mhm.
do they know? How they don't know that? Because of the cookies, right? So you can tell Facebook, I want to target all the people that visit clothing stores, right? So Facebook is gonna gather all the people that have been to Macy's, JCPenney, Abercrombie and Fitch, Hollister, American Eagles, all those stores online. Facebook is gonna grab all that information and make like a packet and give it to you, okay? And give you those customers whom you can target for your business. So every time you go to a website, there are cookies there. And many times when you go to a website, here in the bottom of the screen, it says, we're using cookies for a better user experience, accept or decline. And many times we accept it, and then those people will use the cookies, to supposedly help you find what you're looking for. Okay, so cookies are important, and they have an expiration. They have a time to live, also known as TTL. Okay, so it establishes the duration of the validity of each cookie, automatically updated after its duration expires. Okay, so application control session stickiness. This is a feature that the elastic load balancer has, stickiness, right? It uses a special cookie to associate the session with the original server that handled the request. So let's say that I'm accessing a specific EC2 instance, but the elastic load balancer I'm accessing that EC2 instance through has a stickiness feature enabled. So it binds that EC2 with me that makes the request. So if I go to that, if I access the information again, the elastic load balancer, what's it gonna do? Because let's say that you have 3 EC2 instances, right? You have 3 EC2 instances, and then you have the elastic load balancer here, right? So what it does is it distributes the traffic to the three instances, right? 3 instances. But if you make a request, let's say user 112 makes a request to a specific EC2 instance, and the elastic load balancer has the stickiness feature enabled, what's going to happen is next time when you user 112 request information again, it's going to take you to the same EC2 instance, right? To the same EC2 instance, because it has the stickiness feature enabled. Now, a stickiness is good because you still bind the user to that one. But the problem is that if that EC2 instance is down, that stickiness feature, it restricts the scalability, right? Because I am bound to that EC2 instance, and that EC2 instance is gone, right? So I cannot scale, right? So this is good when you have you want to bind users to a specific EC2 instance. But if you don't want that, don't use that. It's not recommended, right? Because that limits scalability, right? So follow the lifetime of the application generated cookie that corresponds to cookie name specified in the policy configuration. Load balancer inserts new stickiness cookies if the application response includes a new application cookie. Okay, that's what it does. If there's a new application cookie, what it does is inserts a new cookie, a new sticky cookie. So every time there's a new cookie, it inserts a new one. Okay. If the application cookie is removed or expires, the session stops being sticky, right? Once it's sticky, once it's gone, it expires. There's no more stickiness. Okay. So you have to do it again. Assign multiple that we saw as well. Okay. Assign Same thing. Okay, elastic IP addresses. Elastic IP addresses are static IP addresses designed for dynamic cloud computing. Can be attached to Amazon EC2 instances. Okay, like I said before, if you want to have an IP address that doesn't change when you stop the instances, this is the guy, the elastic IP address. It is free. One is free as long as it is attached or associated to a running EC2 instance. If the EC2 instance is not running, you're going to be charged. If the elastic IP address is not attached to a running, if it is disassociated and not attached to any EC2 instance, you're going to be charged for that. Be careful with the elastic IP addresses. So enable you to mask the failure of an instance of software by allowing your users, a client, to use the same IP address with replacement resources. Keyword, mask the failure. It masks the failure. Why? What happens if you don't have an elastic IP? And if your EC2 instance is terminated or stopped, what happens? You're going to be assigned a new IP address, right? And if the user realizes that, the user is going to think that something failed. Something probably failed because you have a different IP address. But what happens with the static IP or elastic IP is that, as it is always the same IP address, it masks the failure. If something failed and a new instance was created due to auto-scaling, then the user will never know that a new instance is running because it has exactly the same IP address. So that's a good feature of elastic IP addresses. I love that. So enable HA. So we have here application clients. We have a mobile device and we have a desktop computer. So what do we have here? Application server. If one instance goes down, clients can use the same IP address to reach the replacement instance. So let's say that this application, the static IP or the elastic IP address was 192.1.68.2. Okay, so this is go down. This one is going to have exactly the same, right? Exactly the same IP address as this one. Okay, no one will notice that this one failed because this is only in the back end. It's in the back end. You know, you're not watching this. You don't know anything about this. You just know that there's a server running and that's it. But you don't know which one exactly is running, an old one or a new one. Okay, which is pretty good. Okay. So we have here do yourself, right? Do it yourself load balancer versus elastic load balancing. Okay. If you do yourself, it's going to be a pain in the neck. So it's not managed. It's managed by you. Okay. So you have to create a load balancer manually, which I don't recommend. Creating a load balancer manually. And then it has to fit the requirements for that particular EC2. Okay. And scaling must be handled by you. So you have to be sitting in front of the computer, right? You have to be creating EC2 instances manually, one by one. You have to wait for EC2 instances to fail and then create a new one. So I don't think that's a pretty good idea, right? I would go for this one, which is managed by AWS. Usually the most cost-effective solution because you don't need people for this. You don't need resources for this. You just need the AWS console and that's it, right? Automatically scale. You know, it's automatically scale. You don't have to scale it manually like here, that it has to be handled by you. Okay. Now, connection draining. What is connection draining? It enables connection draining. What it does is causes the load balancer to stop sending new requests to the backend instances when the instance is registered or become unhealthy. So whenever you hear connection draining, is the time when the EC2 instance shows unhealthy and the load balancer stops sending traffic to that instance. So that's the connection draining. Okay. Why is this important? Because you can perform maintenance without affecting your end users. Okay, you can do that without affecting the end users. Now, enable connection draining through, you can do it through the console manually. You can go there and do it manually. You can do an API call. That's mostly for developers. AWS command line interface. You can use CLI, or you can use the CloudFormation. When you create an Elastic CloudFormation, Elastic Load Balancer in CloudFormation, you can enable that feature, connection draining. Okay. Now, I don't know if I said this before, but whatever you do in the console, you can do it in the CLI. Okay, you can do exactly the same in the CLI. You just need to become more familiar with the CLI and completely almost master the CLI, master the codes and everything, mostly Linux, because the CLI, AWS CLI is made in Linux. Okay, and you know, just get really familiar with the code, the command line commands, and thank God we have the AWS documentation, what you can use to know all the commands. For example, let's say AWS run, let's say AWS, let's say AWS CLI load balancer. So we, you have these guys here. Maybe you have the user guide. What is CLI? Installing the CLI, configuring, using the CLI. So we have command structure. In the command structure, we have user AWS command, you know, suc command. You know, command is the service, EC2 or S3 or ELB, Elastic Load Balancer. And then the options that we have in the case, like we did this morning in the AWS class, like we say EC2 here, and we say run instances, and then dash image ID, dash count, dash security group groups ID, dash region. Those are the options, right? So if you want to know more about how to, just in case you have several load balancers, maybe you can say describe a load balancer, and it will tell you the information about the load balancer, give you all the description. If you want to go for a specific load balancer, you can say dash load dash balancer dash names and put the name of the load balancer, and then we give you all the data about that particular Elastic Load Balancer. Okay, so the CLI is great. It's great, right? So maybe if you want to probably create an Elastic Load Balancer, probably it should be here. If you want to create an Elastic Load Balancer, you can write this in your CLI, and then create a load balancer instead of doing it in the console. In the console manually, well, they're both manual, but instead of going page by page, just can do it just one line of code. I just put create load balancer, the name of the load balancer, the listener, if it is port 80 or port 443, in what availability zone you want to put it, the subnets where you're going to put it, the name of the security group of the Elastic Load Balancer, the scheme, the tags, if it has any name, the input, if it is JSON or any other input, you know, and the CLI skeleton if you want to generate one. So it's pretty, I mean, it's pretty helpful, the CLI. I recommend taking a course on Udemy or, you know, online, any course that has to do with the CLI in AWS. And if you use the documentation from AWS, I think it's going to be pretty easy once you get the grasp of it. Okay. So exercise, improve this architecture. How can we improve this architecture? Tell me, please. So based on what we've seen so far, what is missing in this graphic? Can you tell me?
An elastic load balancing.
Elastic load balancer, right? How are we gonna distribute the traffic here? Is it gonna be evenly distributed? Okay. Are we gonna have here? Do we have health checks? Is it highly available? Completely highly available? So we need these guys, right? We need these two guys here. Okay. We need this elastic load balancer here for these two guys here, right? Don't forget that in order for you to have this load balancer working in these two availability zones, we need to enable cross zone availability. Okay, don't forget that. So two types of load balancer. We have an internet facing one because this is the one that it's facing the internet here through the internet gateway. We saw it last class, the internet gateway. And we have an internal load balancer that it's internally, right? It's internal. I mean, no internet is accessing this load balancer just as it is this one, okay? This one is being accessed by these web servers that I'm trying to get the information from this servers here, or databases here, or private servers, right? But they're gonna do it through the elastic load balancer, but the elastic load balancer is an internal load balancer, okay? So again, as it says here in your left-hand side, internet-facing load balancer, this one here, okay, is deployed in a public subnet, right? In the public subnet, okay? Balancing traffic to web browsers in two availability zones, right? This one and this one, right? Now, the elastic load balancer, internal one, is intranet facing on or internal. So this is internet facing and this is intranet facing. Why? Because it's gonna get the traffic only inside this network, okay? Now it distributes the traffic to your TC2 instances from clients with access to the VPC for the load balancer. So it's gonna distribute the traffic from these guys, okay? So you wanna be more highly available, right? So we use these guys, right? Before, you can access this guy, right? Using what? A NAT gateway, okay? You can use a NAT gateway, okay? But you don't have distribution here. You don't have a guy distributing the traffic to the three instances. But if you have this guy here, it will distribute the traffic evenly, and send health checks to these EC2 instances to make sure that they're all operational, right? Across region. So we have here Amazon Route 53. When we have this guy, that is a high level. We are in a different dimension. Okay. When we use Route 53, which is a global service, okay, it's a DNS service from AWS with the following characteristics. DNS translates domain names like Amazon to an IP address. I don't know if I said this here, but a DNS is a service that what it does is it's a domain name service. What it does is translates domains into IPs. Right? It resolves domains into IPs. Why? Because a machine doesn't understand www.amazon.com. It doesn't understand that. What a machine understands is a 122.168.1.2.1.3. That's what the machine understands. An IP address, which is, by the way, a binary thing. Remember that IP address has 32 bits. It has 4 octets, okay? 4 octets. Every octet has 8 bits, right? So that's what the machine understands. The machine doesn't understand domain names. So Route 53 is the service that AWS has to translate domains into IP addresses, okay? Why is it called Route 53? Simple, because the port that DNS uses is 53. Okay, So far, we're seeing mostly like 3 ports. We saw port 80 for HTTP, I'm sorry. We saw 443 for HTTPS. We saw 22 for SSH, and now we see port 53 for DNS, okay? And it was called route because it's named after an interstate highway in the United States, like a route. That's why it was put route, okay? So Route 53, okay? The name referred to the fact that the DNS server responds to queries on port 53, okay? So this is a high new level, okay? We're working globally, right? Here, we're working, in a specific zone, 2 zones in a specific region. If we want to do it across regions, then we have to use this guy. So this guy will work in conjunction with Elastic Load Balancer, which in conjunction works in turn with the auto scaling feature. So there are 3 guys working together: Route 53, Elastic Load Balancer, and auto scaling. So those guys are coming together like 3 brothers and helping for high availability. So that's a very cool feature that AWS has. So Amazon Route 53 DNS resolution. Okay, so we have this here. So we have here Amazon Route 53 DNS resolution. So we have here a basic pattern of Route 53 follows when a user initiates a DNS request. For example, example.com is typed in your URL. So it goes to a DNS resolver right here. What it does is it checks with your domain in Route 53, right? And the DNS gets the IP address there. The IP is 1234 and returns it to the user, right? That allows the user to get to the website without having to memorize the IP address, right? Can you imagine if we have to memorize the IP address? So humans don't work with, they're not used to typing 1.2, 1.3, 1.4. This one is easy, right? It's just a sequence, 1, 2, 3, 4. But in the case of very strange, different bit octets, IP address of the 164, 3, 198, 2, that's crazy. You don't have to remember every single IP address of every single company. That's crazy. So you just type example.com. In this case, you can do amazon.com. So it comes to the DNS resolver, okay? What it does is goes to Route 53, gets the IP address, sends it back to the user, and then the user can access this website. Okay, that's basically what happens behind the scene. You don't see it. You don't see it. Okay, so this is exactly what is happening here. Okay, when I do this. Okay, right? It's super fast. We don't see it, but this is what happens, right? Okay. Okay, so it goes here, it goes to that particular DNS resolver, and then gets that, and then it comes back with a status code 200. I don't know if you see here.
No, can see it.
No, the developer tool here doesn't increment. It doesn't increment as I increment the page. But what it does, if I go to any website, you see here the network, at least you see a bunch of commands here, a bunch of things. If I go, for example, to amazon.com, you see, It's a lot of, these are things that are happening right now in your website. This contains all the links and all the pictures and everything. For example, this one is a picture. This one is a picture. If I preview here, see this one here. Somewhere in this website, this picture is somewhere. Okay. Let me see. Somewhere here. Okay. This is another picture. Tweet that one. Let me see. Is one of these books here. Okay, it doesn't matter. It's just it's to show you that when the page loads, it loads everything. It's a picture and everything here in this website. And if you see the header here, it has a 200 status code. It means that when the request was made, everything went well, okay? And it came back telling me everything is okay, right? So the status code 200 means everything is okay, okay? That's what it means. So behind the scenes, there are a lot of things happening, right? A lot of things happening. Now, let me see if I can, let me see something here. Let me see if I can, all right, so you see this IP address here? Okay, you see this IP address here?
Yes.
Okay, let me copy and paste this. Let me see what happens. So my router is blocking this. Doesn't let me see it. But you know, Amazon, behind Amazon.com domain, there is an IP address that can be used to access Amazon website. Okay. That's basically it. So Amazon Route 53, it's reliable because redundant. It has redundant locations. It's backed with 100 service level agreement. You know the meaning of that? It means that it is 100% guarantee. Okay. Other services have an 11.9 service agreement. But Amazon 53 is a tier 0 service, meaning that it is designed and maintained with the highest level of availability in mind, the highest of all. Okay, it's a tier 0 service. Okay, it means it's the best of the best. Okay, so it is fast, worldwide anycast network, fast propagation of changes. If you change something in Route 53, it will propagate real fast around the world. It's integrated with AWS ELB alias queries. You can make queries to ELB and latency-based routing. We're gonna see those routing policies in a moment. Okay, it's easy to use. You can use the console. You can use programmatic API. You know, SDKs and all that, domain name management. You can use all that. Okay. Inexpensive rates is not expensive, and it has a pay-as-you-go model, right? pays as you go. Geolocation routing, okay. Weighted routing, round robin, and self-aliases, okay. Now we're gonna see that. Okay, there are 7 routing policies that Route 53 has. This is what you have to remember, okay. This is what you have to remember. So simple routing, simple server, single server environment. So you have, you know, it's routed to one server. That's it. Simple routing. Okay. So we have 3 servers. It's just route to one, or route to the other one, or route to the other one. It's just single, right? Only one. That's what single routing means. It uses a simple routing policy for when you have a single resource that performs a given functions for your domain, such as one word server that serves content for example, the example.com website. Okay. In this case, Amazon 53 responds to a DNS query based only on the values in the resource record set, like the IP, right, IP address in an A record. So basically, what happens is that here in the console, we have something called Route 53, right? Okay. So in my case, I have a hosted zone. I created it already with this website that I have, right? So I can, for this guy, right? I can create a record set, okay? Right? Create a record set. And here, I can select the routing policy, single. Okay. And this is the time to live seconds. It could be more, it could be 1 minute if I want, okay. And then I can select here a CNM, a CNAME, you know, text record. If you know a little about, you know, this routing thing, for example, when you buy a domain, you have to provide some CNAME records and TXT records, just in case you want to confirm. For example, if you have with GoDaddy, if you have a domain with them, you have to put a TX record there because they want to confirm that is yours, is your domain. So they will ask you to put a record there, and they will confirm it when it's connected. Okay. If you're having, for example, an email service with let's say, let's say Outlook. Okay. You have, when I have email services, let's say you have a domain and you want to purchase a domain service with, and as a mail service with GoDaddy, you will have to put in your domain provider, the register, some MX record to route all the incoming emails or outgoing emails to that particular website or that domain. So it's a little, you know, it's a little tricky, but basically, if you want to know more about Route 53, you should have a video today. But Route 53, what it does is it works with domains, and you can create record sets. And here in the record sets, you must establish the routing policy that you want to have. Okay. Now,
I have a question.
Go ahead.
So does this mean that if you are multi-region, you have to do your hosting of your domains with Amazon?
No, no. You can bring your own domain here.
DNS resolving.
Yeah, you can bring your own domain here. Okay. You can create your domain here. Actually, this domain I didn't create it with AWS. I brought it here. I created a hosted zone and I attached this domain to this hosted zone.
Oh, okay.
Okay, but you can create one if you want to.
So
domain.
does Amazon also allows you to create domains?
Right here, right here.
Where are you? Oh, register domain. I got it.
Yeah, you can create the domain here. You can look for, let's say,
Oh wow, it's cheaper than GoDaddy.
let's say that, say Dunieski Otano. If I check, it shouldn't be available. It shouldn't, you see, because I already have my website. You see, I already have my website with my certifications and everything. You know, my certifications here. It has to exist, right? But if I say Dunieski Otano Ramos, my second last name, if I check, it's available, right? $12 a month, a year. So I can add it to the cart. I can purchase it, you know. So you can purchase a domain using Route 53, or you can transfer the domain.
Do they do .org also?
Which one? What?
.org.
I cannot understand what you're saying.
And they do .orgs.
Yes, yes, they do all of them. Yes. Let's see if they give me a suggestion for Dunieski Otano that already exists. You see. It's right here.
Okay.
All right. So you have the choice to do it here or bring your own domain. Okay. Which is pretty cool. You know, it's everything in a single stop. So, you know, AWS thought about everything. When they decided to come to the market, they thought about everything. And throughout the years, they have improved this technology more and more and more. Okay.
Where is the window for that? In the console, where do you get Audi there?
Yeah, in the console, like if we find any service here, right?
And what did you choose?
Services.
Yeah, but what did you search
Oh,
for?
Route 53.
Oh, okay, got it. Thank you.
You're welcome. Or you can come down here. Oh, by the way, this is remember you mentioned IoT this morning? It's right here. It's right here. See, IoT device. Okay, so you can come here to Route 53. It should be somewhere. I think it's in the networking.
Alphabetical order, if I remember.
Networking section should be there. Networking. This is migration. Right here. Networking.
Delivery.
Yeah, networking. Yeah, they're here. Find a VPC and Route 53 and Direct Connect as well. Okay, so so this guy is amazing. This guy is one of the most powerful guys in AWS, and basically, you know, you can be global and highly available, super highly available in the entire world. Okay, because you know when we started in our class, not this one. Other classes that have nothing to do with high availability, they tell you that you can create services globally and all that, but when you integrate these guys, that's a whole different level. These guys, they take you to heavens, just to say, you know, so to speak. So weighted round robin, assign weights to record sets to a specific frequency. So what it does, what it does is that you may have four EC2 instances, and then you want each one to receive 25% of the traffic. Okay, only that. Okay, so we have 100%, right? So and then each one is going to have 25%. So you are weighting the distribution of traffic. Okay, that's what you do. Okay, that's simply weighting, round robin. So you assign weights to resource record sets in order to specify the frequency with which different responses are served. Okay, that's what it is, right? So if you have any questions in the exam that has to do with a specific percentage to um, specific EC2 instances, this is the one that you use. And this is the one that you use for blue-green deployment, blue-green deployment. So in the blue-green deployments, you're going to move your infrastructure to another set of, let's say you're going to move all your servers to another set of servers, but you don't do it all at once. So you're going to send first 10% of the traffic. You're going to test it, right? To see if the blue, which is the, the blue is the old one and the green is the new one. You're going to see if the green set of instances are working okay with 10%, okay? Everything is fine. So after, let's say after 10 minutes, this is all automatic, okay? This is automated. You don't have to do anything. You just set it up and that's it. You, after, let's say after 10 minutes, then move the remaining traffic, which is 90%, to the green set of instances. That's what blue-green deployment is, right? This is, you know, you wanna make sure that all your instances in your new deployment are working fine. Send 10% of the traffic first, they're working properly, then send the remaining 90%. So for that, we're gonna use weighted round robin, okay? So weighted round robin is very helpful when working with this deployment, okay? So latency-based routing, it helps you improve your global applications, right? So what does it tell you? Latency-based. Can you guess what it means? Can you guess? No? Maybe? Yes? Perhaps?
I mean,
Okay.
it's more like essentially you route based to what is closest to you, or like to minimize or lower the latency that you could potentially get.
That's right. So you're gonna route your users to the closest location to reduce the latency. Okay, which is pretty good. So far we've seen 3 routing policies, and so far I like Route 53 already, because these 3 are great. Okay, so guys, let's take a 10 minutes break. It's 2:27, and I'll see you here at 3:37.
Professor, I have a question.
Yes, go ahead.
If I own a domain in Route 53. I've owned it for quite some time. But I've never really understood how to, I guess, like host the website. Is it possible to use an EC2 instance that's connected to Route 53 to then bring up and host my server,
Yes.
like my web server?
Yes.
Okay.
Yes.
If I ever need help, can I ask you like after class how to properly do that? Because there's some I wrote an HTML like script to like I guess make like a simple interface for like my website that I kind of want to build. Can I show you that after class?
Yes. For that one, it is better to use Elastic Beanstalk. It's much better. You said HTML?
Yeah, I mean it's written in HTML. Can't talk. HTML.
HTML. It's better to use Elastic Beanstalk and upload the code, and it will create a server for you. Because,
Okay.
you know, it's much more difficult to make to just put the entire code in the user data.
Yeah, I've noticed that right now that people use FileZilla to transfer the data between their host computer and a AWS server.
Yeah, I would recommend using Elastic Beanstalk. Elastic Beanstalk will create the server for you. You just put the the platform that you're using, and then it will create everything, all the servers and everything, and put it online.
Okay.
It will provide a domain for you, and then you click on the domain, and it will show everything that you put in your code.
Okay.
Okay, so health check and DNS failover to a backup site. If your primary site becomes unreachable, usually what people do is they have like a static website just in place, just in case your website fails. So customers would not notice the change, right? And for this, AWS uses the failover routing policy. When something goes down, let's say that a region goes down, for this DNS, Route 53 will fail over to the other region. Okay, so in the case of regions, we have Route 53. Okay, so that's what the DNS failover does. Okay, this routing here. Okay. So geolocation routing, a specific geographic location by continent, by country, or by state in the United States. Okay, so what it does is, you know, it reroutes to these specific locations that you can, you know, pick specifically. So this one is very close to geoproximity. Okay, geoproximity. The geoproximity, what it does is, you know, it routes the users, you know, where the physical distance is the shortest one between the users and the resources. Okay, the difference between this one latency is the latency doesn't have to do with the distance. It has to do with the speed, right? With the speed, it depends on the speed. Of course, the closer it is, the faster it's going to be. But distance has to be more with geoproximity. Okay, so you're going to reroute your users to a place that they are closer to, where your resources and your users are. So that's basically it, right? Multi-value answers. It has the ability to return multiple health checkable IP addresses in response to DNS queries as a way to use DNS to improve availability and load balancing. So with multiple answers, if you want to route traffic approximately randomly to multiple resources, such as web servers. You can create one multi-value answer record for each resource and optionally associate an Amazon Route 53 health check with each record. For example, suppose that you manage an HTTP web service with a dozen web servers that each have their own IP addresses. No one web server could handle all the traffic. But if you create a dozen multi-value answer records, Amazon Route 53 responds to DNS queries with up to 8 healthy records in response to each DNS query. So Amazon Route 53 gives different answers to different DNS resolvers. If a server becomes unavailable after resolver catches a response, the client software can try another IP address in the response. So basically what you do is you create several record sets, okay, with different multi-values, okay? And what it does is it may request queries to every single one and get the information from one, right? Not from all of them. But if one is not available, it will pick us up from another one. So that's what it does to make it highly available. Okay, this is pretty common to use multi-value. Okay. Amazon Route 53 DNS failover. Route 53 tracks health status of the resources and take action when error occurs. Configure failover with Amazon Route 53. So you can have here in the advanced configuration, the failover threshold, like number 3, you know, the seconds it would take. Stream matching, no. Latency graphs, yes. So you can fail over when one region is down. Okay. So that's basically what failover does. You know, you have to configure it here and put the interval. If it is standard or fast, you know, the faster, the more you're going to pay, right? The faster the interval. Of course, the smaller the interval, which is the faster. And you can configure backup and failover scenarios for your own applications. Of course, when you do failover, you know, it's good to have a backup in place because one region is down. And let me tell you something, a region can be down completely, the entire region, okay? So it's good to have a cross region replication just in case, you know, your entire region is offline, you can still be operational. Okay, so improve the health checks by combining multiple health checks, domain name based health checks, stream matching, specifying the request interval, and more. So health checks are super important because that's what guarantees that an EC2 is either healthy or not healthy, and that's what guarantees that the traffic will be sent to the operational instances, not to the ones that are not functioning at the moment. Okay, so here we have multi-region deployment. So this is a DNS of an elastic load balancer. Okay, I'm gonna create an elastic load balancer today when we finish with this slides. And whenever you create an elastic load balancer, it's gonna provide you with a DNS, okay? And then that's what you're gonna use to access the EC2 instances. So we have another elastic load balancer here in AP Southeast 2, which is a region. I think it is Japan, if I'm not mistaken. Japan, something there's Asia. I mean, I think it's Japan. And here you have US West 2. This is the United States, right? So even though this is Australia, right? Australia, not Japan. So Japan is something similar. Okay. So we have Australia here. So we have 2 elastic load balancers. Whenever you see these guys, this symbol, that's elastic load balancer. Okay. So we have a user here, right? And we have here the name, MG Go Green, or AM Go Green. We have the alias. Here we have the the domain, the DNS of the first elastic load balancer, the one in the here in West 2, US West 2, and then we have the same name and alias, and here we have the alias, the value. It's in Australia, right? So you can deploy this guy in different regions, right? Using 2 elastic load balancers, one on each region, okay? By creating 2 aliases, right? So when people go here to this domain, they're gonna be routed to whatever location is closest to them, okay? So the user is here. Guess where the user is gonna be routed to?
The one in the US.
In the US, right? Makes sense, right? Makes
Uh-huh.
sense. But what if the US goes down?
Then the other one takes over.
You go to Australia without flight ticket.
If yeah, and in a matter of seconds.
Right.
Okay, that's
So let's say the user is in Africa, for example, in Cape Town.
It's going to be routed to the closest of these 2, because you have deployment.
Is it the closest or the fastest?
Well, the closest is the fastest too, because latency has to do with the distance.
Mm-hmm.
Okay. Now, latency is speed, right? Now, you have only 2 deployments here. Okay, you're deploying in the United States and you deploy in Australia. But what if you deploy in Africa? Okay, if you're deploying in Africa as well, you have a region in Africa, right? Then you're gonna be routed to Africa. Okay.
No, but there's nothing in Africa.
And that's right. That's right.
So if I have a user in Cape Town, right, the southern part of Africa.
No. Matthew bought a house.
Hello, excuse me.
Hello. Please mute your mics, please.
So if I'm in the Cape Town, which is the southern part of Africa, right?
Yes.
Is it going to, let's say that I go to amgogreen.com.
Mm-hmm.
Is it going to test which one is the fastest and then route me there, or?
It's like we spoke before. You have to choose the routing policy.
Oh, okay. Okay. So it's part of the policy. Never mind.
Let's say that you want to send 80% to Australia and 20% to the United States. Okay. If you choose the weighted, if you use the latency-based routing, it's gonna send it to the closest and the fastest one. Okay, of these 2. If the customer is here, it's gonna come first to the United States because it's the shortest distance. It's the lowest latency. Okay. If the user is here, for example, it should be this one, right? So it depends on the routing policy that you choose. Okay. So you have 7 routing policies that you can choose from. Okay. Remember, this is all set up before you do anything, right? So you have to be aware of your deployment, where it's going to be, what region is going to be, and then based on that, you can choose your routing policy. Okay. So typical architecture, you have a record set, CNAME W, elastic load balancer, routing policy failover, for example, record type primary. You may have 2 record sets here. One is the primary, and the second one is the secondary, like here. In the case of failover, let's say that you have 3 regions, and one region goes down. Which one is going to be the primary, and which one is going to be the secondary? Okay, just in case, that's in case of failover, right? So let's say that you have the United States as a primary policy location, just in case of a disaster. All your users are going to be sent to the United States, right? Because that's the primary. And then the secondary, just in case one goes down. And then you're going to be sent. The bottom line here is that you have to be available one way or another. So you have to plan ahead. You have to see what routing policy fits best, and you have to see where you're going to deploy. Okay, in what part of the world are you going to be deployed? Okay, the more regions you have, the more available you're going to be, but the more you're going to pay, right? If you're only one region, you know that if this region goes down, you're screwed, right? It's very unlikely, not completely unlikely, but it's unlikely that the entire region goes down, but you never know, okay? You never know. If you're a huge company that is global meaning that you have, branches all over the world, you better get from Route 53, okay? So we have this guy here, Route 53. It's like it's like a highway sign. You see here, similar to a highway sign, because it's based on that and a highway and port 53. So you have here the user is just going to the primary location here. So you come to the last load balancer. The last load balancer gets the distributed traffic in the two Amazon EC2 instances, right? And this has a CloudWatch right here. Okay, this is CloudWatch metrics. Whenever you see graphics and all that, that's CloudWatch. It's gonna give you a dashboard. Okay, let me show you. One moment. So if you go here to services and you click and you type CloudWatch, okay. So we have this guy here that gives you metrics, okay. In this case, I have a Lambda function. I think that I created a Lambda function on Wednesday. It says insufficient data because I haven't used my Lambda function since Wednesday. Wait, you see, I created on Wednesday, my first Lambda function. If I click on that, it would take me to my Lambda function, right? It's right here, the one that we created on Wednesday that said hello Lambda, hello from Lambda. So I can go back to my CloudWatch. And in my CloudWatch, I can just select here by EC2 instance. And I don't have any EC2 instance right now, right? So I don't have any data or anything. Okay, I don't have any data. But this guy can give me some metrics every hour, every 3 hours, every 12 hours, every day, every 3 days, every week, and you can customize it every minute, every 5 minutes. The lower you go, the more you're gonna pay, because this is a luxury to have metrics every minute or every second or whatever low number. You have to pay for that, okay? And you have to enable detail monitoring, right? But this is basically having some metrics in your infrastructure, like CloudWatch right here, okay? So you have an EC2 instance, and on top of that, you have CloudWatch registering and measuring your health, your EC2 instances health, and everything here, right? So we have here the two instances grabbing all information from this database, okay? For this master's database, master. And at the same time, this master, it's replicating this information to this standby database, right? So let's say that you have a website, right? A website that is being picked up from here, okay, from these servers, right? Let's say that this this site here is down, right? It's completely down. What's going to happen? Route 53 is going to come here to Amazon S3 where you're hosting a website, right? You're hosting a static website, which is the secondary type, record type, right? The first one is gonna be this guy here, this last load balancer. As you can see here, last load balancer. So the first one is gonna be a last load balancer. Every single request is gonna come here. If everything is fine, everything will come here. If something goes wrong at this this primary record type is gone, okay, then you're gonna come here to the S3 bucket and grab there the static website, and it's gonna look like nothing happened, right? Because the website is there. Okay, now it's gonna be there up and running until this one is fixed. Okay, this is when the development team or the recovery team or whatever team works on that is gonna come here and fix this. Okay, but in the meantime, there is a website that is up and running, so you don't have to worry about that. Okay, so let me show you when you create an S3 bucket. So you come to your S3 bucket, right? And I have here 2 buckets, one for the video Monday for the cloud practitioner and one for the video Monday for the solutions architect. So I can come here, click on one of the 2, and then
Can you zoom in?
yes, why not?
Thank you.
Yes, so I can come here to properties, right? Properties. And one of the properties that I have is static web hosting. See here? So I can use this bucket to host a website. Okay? So in this case, I'm gonna have a file by the name of HTML, right? Index HTML, right? And then when I click on this guy, it's gonna give me that content. If I click now, there's nothing. Okay? If I click now, there's nothing there. But if I have in the HTML file, let me try something here. Let me see if this works. Okay. So this is a solutions architect. Okay. Let me upload a file here. I'm gonna make it public. Okay. Now, if I come here to management, properties, I'm sorry. And then I have this guy here. You see there? Remember we did it this morning?
Yes.
Brian, are you looking at this?
Yeah, actually, I just got my website running. Like, I was
Okay.
actually Googling exactly this while you were doing it.
Okay, so you can host your website. This is now global. So if I post this in the chat, okay, and you click on it, please click on it. It is not on my computer anymore. Try to paste that in your website, in your browser.
Yeah, I see it.
You see, that's a way
Yeah.
that you can host a website a static website as simple as that. Okay, you just write your your HTML file and then upload it to your S3 bucket, enable static website hosting, and then it's gonna host that for you. Now, let me tell you something. It is super, super cheap. I think it's like 0.05 cents a month or something like that. It's super cheap to host a website with Amazon S3. Okay, but you see how cool it is. So
Yeah.
in your case, Brian, don't waste resources going and using Elastic Beanstalk. Okay, so basically you don't need an EC2 instance for this, right? So you can use your S3 bucket for that. Okay.
What is the difference between this and Amplify?
Amplify is more expensive, and Amplify is mainly used for serviceless applications. So here you don't have an application, you just have a static website. Okay. With Amplify, you deploy applications. That's a huge difference.
Okay.
Let me see Amplify here. Amplify is a new service from AWS. It's super, super, super good and fast, everything. So build and deploy. You can do several things at the same time. You can grab
This for responsive websites? Is that what the reason why they did this, or?
no, responsive has to do with the design of the website. Okay.
If you look at the top, can you look at the top? Yeah. Can you go to the top? Is that the top part of it?
This is the top.
Oh.
Okay. What you do here is, what it does is everything is in one stop, right? You deploy, you build, deploy, and host, right? That's three things there. Okay. And it's a full stack thing. Full stack, right? A full stack means backend, front end, right? And above all, is serverless. Okay. And it's a web application. What I just hosted on EC2 on S3 is not a website, it's not a web application. It's not a full stack thing. It's only HTML file. It's a static website.
I see.
Okay. So full stack, it's you know, it's a two-sided thing, for back end and front end. Okay. So this guy is super cool. Okay. You can grab your information either from GitHub or AWS code commit. This is very common. Okay. Code commit is the AWS version of GitHub. Okay. You can find here, you can find it in here. You can say code commit, right? And you can have the code here, right? Okay. So I can grab, I can create a repository, right? Like you do in let's say my repo, right? My repo, and that's it, simple. I created a repository, right? So now what I have to do is I have to load the code here, right? I can load the code here. So I can do it manually, right? Or I can do it from the CLI, whatever I want. So I can come here and just find out for the index HTML file, right? I'm gonna put it here, but the author is Dunieski. You know, like when you commit, my email is gonna be example.com.
Mm-hmm.
And I just uploaded an HTML file, right? So I can Committed. Okay. So the code is going to be there, right? Now, if I go to Amplify and I start my thing here, I can get it from code commit, right? And I can choose my repository, my repo, right?
Mm-hmm.
My branch is going to be the master. What happened here? Oh, my page froze. Okay. Oh, it froze. What happened here?
We're still here.
Oh, I'm moving. You see, I'm not moving in my camera.
I know.
Yeah,
Mhm.
your whole thing froze.
Wow, man.
You have too much stuff open.
No, I have 32 gigabytes of RAM in my computer.
Oh, I wonder
so-
why. What happened?
Okay, one moment. Oh my God. It's a good thing that it happened at the end of the class and all the content is mostly taught already because the live, okay. Guys, I will have to do the same that happened on Monday, remember? Monday, I had to restart my computer, remember?
Okay.
So we have to restart my computer. I guess you probably stay connected. I'm not sure about that. So I'm gonna turn my computer off and I'm gonna be back on. Okay?
All right.
I'll be here in a second.
Okay. Yo, Brian,
Yes.
what's your website like for?
I mean, I was gonna just put stuff that I do or like or like just kind of have like a website so that I can kind of like organize everything I do professionally
So like
to
a
kind of
resume?
display it. Yeah, kind of.
All right, that's cool. You said
I
it's
mean,
up?
technically speaking, yes, but I'm still writing like I'm having to change some of the code just because it's not organizing well on the website. So, if anything, I'll send it to you in a second.
All right, cool.
Let me just fix a couple things.
All right.
So guys, I'm back. Can you
Okay.
hear me?
Yeah, we can.
Okay.
Yes, we can hear you.
Okay. I don't know what this is happening. I mean, not so frequently, but it's the second time that it happens.
Maybe it's a YouTube. Is this the first time you do streaming on YouTube at the same time you're doing all this?
To be honest, yes.
So that might be it.
Yeah, but on Monday I didn't stream on YouTube.
Okay.
Okay, so you see my screen?
We see you. We don't see
Yeah,
the
you need to
screen.
share the screen.
One moment. Okay. You see it now?
Yes.
Yep.
Good. So we come here and just look for amplify. Amplify is right here. So then get started again and code commit and continue. I choose the repository. What's going on here? All right, code commit. Okay, what happened? It didn't, okay. Just give me 1 second. Let me see what happened here. What's going on here? Okay, code commit. I have a repo there. I don't have a repo. What happened here? Okay, I created a repo. That's absolutely crazy. Okay, not a problem. I can upload the code again. That's not a problem, right? I can do that. Okay, so I can come here. I can just I can find it now on my computer. I can put it here. And I can do the same thing. Okay. Okay. So I committed.
He's like, I'm making a website and like, I don't know if you can help me out the class. He's talking to the teacher. He's saying, oh, to the teacher.
So now I come to amplify and do the same, code commit, and then now I can see my repo. So I grab my repo and then I got my master, and then from the master, okay, and then I can do this. Then I save and deploy. Let's see what happens. So now it's going to provision, it's going to build, it's going to deploy, and it's going to verify. So now it would take some time, right? It's not a big file. It only has 2 lines of code. So I don't think it's going to take a long time. It already provisioned. Now it's building. You shouldn't have any problem with building because we already tested it with S3 and it worked, right? So building, what it's doing is just checking line by line and seeing if everything is correct. There's no syntax errors or anything. So I build and deploy real quick, right? And I verify. So if I come here to this link here and I click on that, there you go. Right? So I can give you this link and you can check it in the chat, right? And you're gonna have exactly the same information as we did it with the S3 bucket. Okay. Now, what you can do is to create a CNAME or an alias record and put your own domain. So every request that comes to this domain, what you want to do is reroute it to your domain. That's what you want. Okay. Because you're not going to give someone the, okay, this is my website, master.d22u09mbz7nbux.amplifyapp.com. What is that? You know, what kind of domain is that for a professional website? So you want to create a record that what it does is reroutes every single request to this domain to my domain. Let's say duniesquiotano.com. Okay, that's something that you have to do with your DNS provider. Okay.
So it's basically a forwarding with a masking.
Yes, because you want to use your domain. You don't want to use this strange large thing. You know, you don't want to use this. You want to use your domain. You want people, when people type this, you know, this, you know, when people type that, you want this to show. Right? As an example, you want this to show, right? But you have to set that up. You have to set it up. You know, you cannot just expect this to reroute. You have to create a record with this. You can do that with your domain provider. Okay. Mm-hmm. I recommend, this is very cheap. Well, the word says it. Namecheap.com. It's a very good thing to find domains. For example, if you want to find Duniesquiotano, that site, as an example, I'm going to be paying $1 per year. You know, that's cheap, right? $1 per year. Okay.
That's like really, really cheap.
It's 80% off for 2 years.
That's pretty good.
Yeah. So
it's getting too expensive.
yeah. So Namecheap is a good place to get domains. All my domains, I buy them here. Okay. Very good.
What is it again? Namecheap.
Namecheap.com. Okay. So I think the rest of the slides is about the lab. Okay, about the lab, and that's something we're not gonna do lab. We're gonna do it on Monday. Okay. Let me see here. One moment. Yes, on Monday we're gonna do lab 3. Don't worry about lab now. Not for now. Okay. Continue studying the quiz and all that, the quizzes, and continue watching the videos. Next week, I will provide for you guys, I will provide access to the place where you're going to start practicing for your exam. Okay.
I have a question about Direct Connect.
Yes, go ahead.
Is that a physical connection to something that Amazon provides for you to connect your own premises?
Fiber optic. Fiber optic.
But so is it a physical equipment and a digital on a connection, or it's just on the cloud?
It needs internet, right?
Hold on, I need to open up the window. Yeah.
So AWS Direct Connect makes it easy to establish a dedicated network connection from your own premises to AWS. Using AWS Direct Connect, you can establish private connectivity between AWS and your data center office or co-location environment. So the feature and the benefits, well, it says here that is a network latency over the internet. So this is over the internet. You're gonna need the internet for this, right?
Okay. So it's basically like a virtual private network provider?
No, actually, no. You don't need the internet for this one. For the one that you need the internet is for the VPN connection. So you have two ways to connect to the on-premises data center to AWS, either VPN, site-to-site connection, or Direct Connect. Direct Connect doesn't need the internet. That's why.
So is Direct Connect, is it a telecom service? In other words, that it's fiber driven?
Yes, it's fiber optic. It's fiber driven. And it's super fast. Okay, it provides 1 gigabits per second or 10 gigabit per second connections. So it's super fast. It's more expensive than VPN. It doesn't need the internet because it's through private connection using fiber optic. Okay, it's like the internet, similar, not the one that we have with AT&T, because AT&T uses private, it uses the internet. But all the connection we have with AT&T is fiber optic. Okay, and this is you can choose the data that utilizes the dedicated connection. It's dedicated only for you. Okay, it's only for you, right?
So does the customer have to link fiber to be able to connect to AWS if they don't?
I think that that might be the case. That might be the case, just in case your area doesn't have fiber optic connected. They're using fiber optic, so it's like, for example, there's some places where you cannot connect AT&T because they don't have fiber optic, right?
Mm-hmm.
Similar to that. This is a very, peculiar and particular way of connecting. Okay, it doesn't need the internet. You know how private it is. And you have a team dedicated for that.
This would be like for government or banks,
What I know is that what I know for sure is that it costs a lot of money.
I'm sure. We're talking about laying out possibly specialized fiber optic cabling and all that good stuff. So.
Yeah, and it's very secure because it doesn't traverse the internet. Whenever you have internet in between, that might be grounds for breaching. Okay, so let me create. I only have 14 people. I don't know what happened to the others. I don't know if they had to leave or anything.
I have to leave at 3:30. Remember.
So guys, don't forget that attendance is important, and it's not cool to leave the class without informing the professor. There are many people that wanted to be in this class and they were put in a waiting list because it's very convenient to have a class like this one, especially that is free. And I'll be considering the attendance every day, just in case, and I will be sending an email to all the students that are not participating,
Can I ask you a question?
Go ahead.
Can we use S3 for our personal storage?
For what?
For personal data storage, S3?
No. Not the best place for that.
Okay.
The best place is Secret Manager. Okay.
What is that?
Secret Manager.
Secret Manager.
Okay, use Secret Manager to store, rotate, monitor, control access to secrets such as database credentials, API keys, auth tokens. Okay, this guy. Okay, this is a guy to store your credentials. Okay, don't use S3. You may have a question in the exams that puts several scenarios, and they give you S3, Secrets Manager, database RDS, things like that. Secrets Manager is number one, and number two is Parameter Store. Okay, that's gonna be it's gonna be Systems Manager. Okay. System Manager, and in Systems Manager we have something called here. Where is it? Parameter Store. Okay, so this is where you can save your database credentials as well. Okay, you can put it here as a string or as a secure encrypted password or something. But this is number two. The one by the preferred way is AWS Secret Manager. Okay.
Secret Manager.
Okay, and then Parameter Store. If you have several choices and you don't see AWS Manager anywhere, and you see Parameter Store, that's the place.
Okay.
Okay. But don't do it in S3. Don't do it in DynamoDB. Don't do it in RDS. Don't do it in EC2 instance like you do in your computer. No. Secrets manager or parameter store. And parameter store is in systems manager. Okay. Good. Let me create two EC2 instances, and I want to create a load balancer. Okay. I'm gonna create a load balancer, and I'm gonna show you how it distributes the load, right? So I'm gonna create here an EC2 instance. I'm gonna choose the AMI, like any process. I wonder if this is going live. Yes, it is. Okay. Okay, so I'm just gonna click select here. I'm gonna select the one that is included in the free tier, T2 Micro. So I'm gonna go here, configure, and then I'm gonna create one here, and then in the user data, okay, I wanna put something here. Okay, in the user data, I wanna put this. Okay, one moment. Oh my, what happened here? Oh my God. This mouse is so sensitive. Okay. Okay, so I have here, I'm installing an Apache server. I'm telling the Apache server, let's say, hello from EC2 server 1. Okay. EC2 server 1. Style, color, red. Okay. Okay, so this EC2 is gonna print hello from EC2 server 1. Okay. So I'm gonna continue creating this. Now I'm gonna add storage. I don't need that. The security group. I'm gonna choose one that I created this morning. It's gonna be this one, my security group that has port 80 open for browser. Okay. So I'm gonna continue, and now, one moment. Let me see what happened here. The tags. So I'm gonna give it a name. I'm gonna say name, and I'm gonna say EC2 server 1. Okay, that's gonna be the name. So I'm gonna continue with the security group. I'm gonna choose the one that I chose before. I will continue. I'm gonna just review everything. Everything is fine. And then I will just proceed without a key, because I'm not going to SSH into the EC2. So I don't need port 22 open. So that's the first one, right? It's already here. It's just pending here. I'm gonna create another one. Okay, same process, right?
I have to drop. So have a nice weekend, everybody, and happy Mother's Day.
Yes, likewise. So have a nice weekend and be safe. Okay, so we continue with the second one. And in the second one, we're gonna put here in the user data the same thing, but this time we're gonna put color blue, and we're gonna say hello from EC2 server 2. Okay. So I'm gonna add storage, nothing, add tags, and then I'm gonna give it a tag here and say name EC2 server 2. Okay. So I'm gonna configure the security group. I'm gonna choose the same. Okay, port 80 open. I'm gonna review. I'm gonna launch it now. We're not gonna require any key. So I'll just launch the instance, right? So I'm gonna view my instances now. One is already running. I'm waiting for the other one, right? So you guys paying attention?
Yes.
Yeah.
Yes, following along.
Okay. So we have these two servers. If I go to this server and I grab this IP address, right? I'm gonna see, for example, here, if I do this, this is so weird. Sometimes it works, sometimes it doesn't work. I don't understand this. Oh. Port 80, it's open, and the user data HTTP style color blue, hello from EC2, closing, and then bar. I don't understand this. I did it before exactly the same, and it doesn't work. Echo style color this, hello from EC2 instance 2 server 1, close this, redirect. Okay, let me see. Let's see for the first one. IP address. Let me open in your browser. It doesn't show anything. Okay, let me check something here. Okay, let me stop this instance. Okay, stopping. Okay, stopped. We go here. Okay, select to here. Change the user data. Okay, system. Okay. The I see a way. This is not working. I see a way. So I'm gonna, start it again. Okay, let me refresh it. Let's see what happens now. If I grab this IP address. I don't understand this. Guys, do you try this before? No?
Creating a website.
I've done it on a Cloud Guru when I was doing the cloud practitioner.
We run this EC2 instance with a Linux server. In our cybersecurity class, we did that with the putty command, with the using putty in SSH.
Yeah.
We run this server.
Mm-mm.
It has 480 open. It has 480 open. Okay, anywhere? Anywhere? Okay. And then?
You have taken both HTTP? You have taken both HTTP?
HTTP, yes. Let me see something here. This is weird, man. Sometimes it works, sometimes it doesn't. I don't understand that. I tried the same this morning, exactly the same, because I've done this so many times and I know this by heart. And sometimes it works, sometimes it doesn't. I don't know. I don't know what to tell you. Let me see something here. Let me try an incognito page here. Still doesn't work. Something is wrong with the HTTP Apache server. Something is wrong here. Let me try this again. Let me terminate these two guys. And okay. So I'm gonna launch the instance again. I'm gonna do it again. Sometimes you have to go back and do the same thing again, you know, because so this is server 1. Okay. Okay. This is server 1. Oh my God, it's please. Okay. This is server 1. This is server 1, web server. Server 1. Okay. I'm not gonna add in tags now. So I'm gonna put here this security group that has 8080. Okay. Okay. Let me add something here in the security group. Okay. Okay. Let me add here. It's a 2 instance security groups. My security group, let me add an inbound rule here. Let me edit the inbound rule and let me add here 22. Okay, 22. Good. So now, okay. See. Okay. I don't think this is gonna make a difference, but you know. So now I have this guy here. Okay, so I can refresh this web page here. And I can go back here and here. And now here I can paste the same thing. And this is web server 1. And then here storage, add tags, security group. I can choose my security group that has 22 now. I can review and launch. I can launch and then, no key. And then launch is EC2 instance. Let's see if now we can see something with the IP address. Okay. Okay, now I can grab the IP address. Okay. And now I can, okay, that's different. Okay. It refused to connect. I don't know why. It has port 80 open and it's not connecting. I don't know why. I have no idea why it's not connecting. I have no idea. No idea why it's not connecting. It's supposed to connect. It's supposed to connect. Okay. No. I tried this exact thing. Oh, look at that. Can you see it now? Can you guys see it now?
Yes.
Yeah,
That's absolutely.
Yeah, we see it.
You see, that's absolutely crazy. I didn't change anything. I just been refreshing and refreshing and refreshing. It doesn't work. Okay. So I'm going to do the same for the second one. I'm going to create another one. Okay. And the second one, I'm going to put server 2. Okay. Same thing. I'm not going to change anything. Okay. Okay. And then instead of here, say server 1, I'm going to put here server 2. And then in server 2, I'm going to use here style, and then I say color blue. Okay. Okay. All right. So server 2, and then tag security group. We're going to use the same, right? This guy here, and then we're going to launch the EC2 instance, and then we're going to wait for the EC2 instance to be available. And after that, I'm going to create a load balancer. I'm going to put it in front of those EC2 instances, and it's going to distribute the traffic. Okay. Just waiting for that. So it's already running. Okay, I'm gonna come here and put this guy here. And then the same thing is gonna happen. Not gonna do anything. And then we have to wait until, you know, still initializing here this check status, you know, status check system. I guess that probably that has to do with that. But at least we know that the first one is working. Okay, this one, if we refresh, is working. This one is not. Right. Okay, so it may not fully operational yet, right? Still initializing here. Okay. Still initializing here. That might be the reason why it's not connecting. Okay. So wait a little bit more. Are you following me just by watching, or you're doing your own stuff in your computer?
No, watching you.
I'm personally watching, and I'm taking notes, and then I'm gonna do on my own and if I come to anything, I'll troubleshoot or and just write questions for you if I can't solve it.
Okay.
I tend to get lost less this way.
Yes. Okay, still initializing here. I don't know why it's taking so long. Okay, it passed that. Still doesn't work. Okay, you saw that I did the same thing. I only changed the number. Okay, I only changed the number. Okay, so let me delete this.
Does this practical comes in exams?
No. I just want to show you so you can have an idea how this can be visible, and then I mean, the elastic load balancer. I don't need the two EC2 instances to show you how the elastic load balancer works, but I wanted to do 2 instances so you can see how it switches from one to the other.
Right.
Okay.
Are we gonna do that in a lab?
In the lab, you might not. So if it doesn't work now, I'm gonna show you the elastic load balancer without that thing. Okay. Oh my God, I don't know why this is not working. I have no idea. Okay, so I'm gonna create the elastic load balancer. Okay, I'm gonna create the elastic load balancer now. So elastic load balancer, you go down here, which says elastic load balancer, and then you're gonna create a load balancer. So you can choose an HTTPS, the application load balancer, networking load balancer. In my case, I'm gonna create a classic load balancer. Okay. So in my classic load balancer, I'm gonna call it my ELB. Okay, my ELB, my elastic load balancer. I can create it being an internal or an internet facing. Remember, we saw that in class. It's going to be listening on port 80. Okay, so whatever comes using port 80 to the elastic load balancer, it's going to continue. The security group, I'm going to use the same one that I use for my EC2 instances. Okay. Now I'm gonna configure the health checks. I don't need any of this, okay, to change any of this for now. I'm gonna add the EC2 instances. I have two right now, so I'm gonna add them to the elastic load balancer. It says here, enable cross-zone load balancing, you see here, okay, is by default checked. I can check it or uncheck it. And the enable connection draining, remember, connection draining is 300 seconds, right? That's the number of seconds to allow existing traffic to continue flowing. Okay. So
both have the same subnets.
huh?
Both have the same IP address, same subnet.
Remember the subnets, I choose them when I create the EC2 instance.
Right.
Okay. So I can come here, I don't want any tags. So this is perfect. The two instances are there. I have here the two IDs, two instance IDs here. Now, oh my God, what happened here? Oh, this mouse is killing me. Wow, man. ELB. Okay, again, the same thing. Okay, gotta be patient with this. Now the two instances, continue, tags, review and create. Okay.
Successful.
So now the last load balancer has, you see here, that's a DNS, right?
Mm-hmm.
That is the URL that you have to use to access now the EC2 instances.
But
okay.
You can change the name, right?
What name?
This DNS name.
No.
If you want to give somebody.
Yes, you will have to give it something more meaningful, right?
Yeah.
So if I do this, oh, wait. I have to wait for the instances to be in service. They are a service now. You see here?
Mm-hmm.
So it means that the instance registration is in progress. So I have to wait for these two guys to be in service. Okay. So right now, the last load balancer is not working yet. Okay. So I have to wait for, now they're in service, you see?
Mm-hmm.
Now I can use the DNS. And there you go. You see?
Right.
You see? Now, when it's using white and blank, there's nothing. That's the other server that is not printing anything. Okay?
Right.
But you can see how it distributes in both servers.
Right.
You see? That's server 1, server 2, server 1, server 2, server 1, server 2. So I'm just requesting information from each server, but the single point of entry is the last load balancer. So I get the last load balancer DNS, and everything has to come through this DNS. Okay? So server 1, server 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. You see how it distributes the traffic? Now, let me do something, a little test here. I'm gonna go and stop number 2. Okay? I'm gonna go and stop number 2. So number 2 is,
which is working right now.
Yeah, number 2 is number 2. It's number 2 here. So I'm gonna stop it. I'm gonna stop the one that is blank, the one that doesn't print anything. Okay. Okay, stopping. Still stopping. You can refresh it and every time and every now and then to see that stopped. Okay. So now here, the last load balancer, if I go to the last load balancer, okay. If I come here, you see the one that I stopped, it says what?
Out of service.
Out of service, okay? Because it's not healthy anymore. So now what's gonna happen is that when I click on the last load balancer, it's gonna show number 1 all the time. You see?
Mm-hmm.
I don't see the blank one anymore. That's why I wanted to print something in the other one. Okay, I wanted to print something in the other one for you to see how it changes from one to the other. But if I refresh and refresh and refresh and refresh, it's gonna be number one only. Do you understand? Do you guys understand the concept behind this?
Right.
Okay. So it's out of service. It's not working properly right now. That's why, you know, instance is in stopped state. Okay. So it will not send traffic to this guy. Okay. So do you guys have any other question?
Not at the moment.
No?
Actually, I have a question. So if you're trying to just use HTTPS because it's I guess secure, would you do that in EC2 by just limiting the port that's open to 443?
Correct.
Okay. As for something like using an S3 bucket, then how would you do it for that if you were using static hosting?
S3 bucket already has its DNS. It doesn't have any limitation when it comes to ports.
Okay, but then how would you convert the S3 bucket to only use HTTPS?
Well, one moment. Let me go to the S3 bucket. So here, management, properties. So here is using this guy.
The endpoint.
Yeah, it's using this guy, and it's not using HTTPS because you need to have another service called CloudFront.
To get a certificate for it.
That's right.
Okay.
So in this case, it's just for a static website, web hosting.
Okay, that's fine. I mean, it's working right now for me. It's just more of like I just want to eventually add more and more to it.
Yeah. Yeah, you can have a beautiful website here and just host it here. But then you will have to, you know, if you want to have a meaningful domain, you will have to change this.
Mm-hmm. No, for sure.
Okay. And of course, add a certificate to make it secure. Okay, guys, if you don't have any other question,